Off the coast of Mauritius lies a visual paradox. From above, the ocean appears to split open, draining into an infinite submarine crater. It visually violates the fundamental laws of fluid dynamics and gravity. But this is not a structural glitch in the planetary surface. The water is not falling, the sand is. We are looking at the steep edge of the Mascarene Plateau. Coastal currents generate immense hydrodynamic drag across the shallow sea floor. The process is strictly mechanical. Silt and heavy basaltic sand break away from the sunlit reef. They are pulled into a violent downward draft. The heavy, abrasive friction of millions of tons of crushed rock begins a continuous slide into absolute darkness. The vertical drop is radical. The seabed plunges to a depth of 4,000 meters. Pouring matter here is equivalent to dropping a steady stream of sand from the icy peak of Mont Blanc straight down into a lightless gorge. Density and gravity drive a perpetual underwater avalanche. How does endlessly falling sand sustain life in the void? This geological escalator operates as a high-speed biological conveyor belt. As the dense sediment cascades down the slope, it pulls a massive payload of organic surface carbon, trapped oxygen, and shallow water biomass along with it. Scavengers and specialized microbes thriving under immense hydrostatic pressure receive a concentrated, continuous delivery of nutrients directly from the surface to the abyssal plain. The downward flow is irreversible. Every single day, this hydrodynamic anomaly drags hundreds of thousands of tons of solid mass into the deep. The 4,000-meter abyss off the coast of Mauritius functions as just one gear in a massive global engine. Earth does not generate scenic vistas for tourists. It operates as a relentless, highly calibrated physical mechanism. Humanity steps in only as a temporary observer. A single human lifespan registers as a mere microsecond against the crushing weight of geological time. 15 isolated phenomena expose the raw power of this planetary machinery. When boiling lava violently collides with freezing ocean water, the elements do not create art. They execute a precise thermodynamic protocol, pure energy transfer, unforgiving physics. Nature produces no random anomalies. Strict physical calculations dictate every single process on the globe. If on Mauritius gravity forces sand to pretend to be water, in Yosemite the geometry of light forces water to pretend to be lava. Horsetail Fall drops down the sheer eastern face of El Capitan, plunging over 2,000 feet. For most of the year, this is just a dry, empty granite wall. But in late February, a ruthlessly precise mathematical equation aligns across the landscape. Cold mountain air bites at the summit, while daytime temperatures rise just above freezing. The winter snowpack begins to melt. A temporary stream flows over the precipice. As the Earth rotates, the sun lowers toward the horizon. Sunset. A single unbroken beam of light slices directly into the narrow geological fault. Azimuth 242 degrees, elevation 2 degrees, wind speed at 0, absolute 0 cloud cover. The massive surrounding rock face drops into deep shadow. The isolated stream of water catches the final solar radiation. Suddenly, the waterfall ignites. It burns with the optical heat of liquid gold, a visual firestorm without a single spark. It is pure, freezing snowmelt carrying the aggressive visual signature of a volcanic eruption. There is no magic in this display, only rigid astrophysics and meteorology converging. The park spans 1,200 square miles. A standard calendar year contains over 500,000 minutes. Yet this exact geometric intersection creates a probability window of strictly 10 minutes. A hard physical lock. The air must provide the water, the sky must transmit the beam, and the wind must remain entirely still to keep the spray intact. If a single high-altitude cloud intercepts the light, or the sun's angle shifts by a fraction of a degree, the equation fails and the fire instantly dies into the pitch-black stone. A supersonic roar shatters the atmosphere above Volcán de Fuego. The delicate optical illusions of light and water in Yosemite are gone, abruptly replaced by a real, brutal release of kinetic energy in Guatemala. The air instantly fills with the sharp, metallic stench of ozone and the heavy scent of burning rock. The mountain is not just erupting, it is generating power. This phenomenon is known as a dirty thunderstorm. The volcano operates as a massive electrostatic generator, driven entirely by the triboelectric effect. The vent violently expels pulverized rock and trapped gases at supersonic speeds, pushing the temperature well above 700 degrees Celsius. Inside this chaotic thermal updraft, billions of microscopic ash particles violently rub against each other. This relentless microscopic friction strips electrons from the fragmented rock, building a colossal electrical charge inside the dense plume. It relies on the exact same physical principle as dragging wool across a synthetic carpet, but scaled up to the raw output of a collapsing mountain. The sheer density of the turbulent ash canopy directly controls the intensity of the storm. For observing scientists, this raw electrical chaos functions as a highly precise measuring tool. By tracking the sharp crackle of static and the frequency of the lightning strikes, researchers can calculate the exact volume of ash rocketing into the stratosphere in real time, even in the dead of night. The volcano effectively acts as an immense static power plant, actively broadcasting its own internal metrics through pure electricity. The low rumble of the Earth merges with the sharp crack of atmospheric failure. A continuous stream of jagged discharges relentlessly pierces the expanding black cloud. Searing plasma shooting up into the atmosphere is nothing compared to the cold chemical machine carving its way to the Antarctic seafloor at -2 degrees Celsius. The cycle begins at the surface. Ocean water freezes. Ice crystallizes. The expanding molecular structure of the frozen water forcibly expels pure salt into the surrounding liquid. Normal seawater undergoes a rapid transformation. It becomes a hypersaline brine, dense, viscous, unforgivingly heavy. While regular ocean water drifts freely, this super concentrated liquid drops like a lead weight straight through the water column. The descent begins. The heavy brine plunges downward into the abyss. Its temperature drops well below -2 degrees Celsius. The extreme salt concentration prevents the liquid from solidifying, turning the fluid into a burning, lethal stream of cold. As this dense chemical river falls, it violently steals heat from the less salty ocean water it touches. A hollow tube of ice instantly crystallizes around the descending core. The brine builds its own containment pipe. It grows downward, relentless. The ice tube strikes the ocean floor. The dense brine spills out, crawling across the seabed like a slow-moving crystalline avalanche. The heavy liquid engulfs sea urchins and starfish in seconds. The paralyzing, burning cold locks them in a tomb of solid ice. Total crystallization, but this localized finger of death serves a massive planetary purpose. A single ice tube operates as a highly efficient microengine. Millions of these heavy, freezing streams bombard the ocean floor simultaneously. Their sheer collective mass physically pushes the dense bottom waters outward. This microscopic chemical separation of salt and ice acts as the hidden ignition switch, launching the immense global conveyor belt of deep ocean currents that circulates oxygen across the entire planet. The underwater engine of ocean currents operates in total darkness, but in the atmosphere, similar thermodynamic machines rise 18 kilometers high and feed entirely on chaos. A standard thunderstorm is a fundamentally flawed design. Warm air rises, cools, and falls back as heavy precipitation, instantly suffocating its own upward thermal flow. The system chokes on its own mass. It collapses within an hour. A supercell operates on a completely different physical principle. It is a perfectly optimized atmospheric engine. At its core spins the mesocyclone, a deep, continuously rotating column of ascending air. To maintain its power, the system physically tilts its vertical axis. This precise aerodynamic angle completely separates the intake from the exhaust. Humid, buoyant air surges up the front edge, while freezing rain and dense downdrafts plunge down the back. The two thermodynamic streams never intersect. Zero interference. Absolute efficiency. The sheer geometry of this machine spans enormous vertical extremes. The rotating storm tower scrapes the boundary of the stratosphere. At an altitude of 18 kilometers, the violent updraft hits the tropopause and flattens into a massive anvil cloud, acting as a high-altitude exhaust vent for the spent air. Down at the surface, the base of the system grinds across the terrain. A singular rotating structure taller than 20 Burj Khalifa skyscrapers stacked vertically, dragging surface winds at over 150 kilometers per hour. The atmosphere systematically organizes raw thermal chaos into a self-sustaining turbine. But from the destructive mechanical power of the supercell, the planetary mechanism now transitions to a hidden, highly efficient chemical energy within the dark ocean, bioluminescence. Leaving the chaotic macro storms of the upper atmosphere behind, the planetary mechanism dives into the absolute darkness of Mosquito Bay. Down here at the micro level, physical impact translates directly into light. A wooden oar strikes the black water. The mechanical shockwave rips through the current. Instantly, the ocean erupts. An electric blue flash ignites along the wake. It moves and shifts like liquid fire. Yet, plunge a bare hand into the glowing vortex and the sensation is jarring. Absolute cold. A visual inferno without a single degree of heat. This cold flame is a strict biochemical defense mechanism. The architects of this phenomenon are microscopic single-celled organisms known as dinoflagellates. The moment an external mechanical force agitates their cell walls, a highly efficient internal process launches. A light-producing molecule called luciferin instantly mixes with a catalytic enzyme, luciferase. The rapid chemical reaction releases energy purely as photons. No wasted heat, maximum visibility, a biological burglar alarm designed to expose predators in the pitch black. The sheer density of this living matrix defines its power. A single gallon of this water holds up to 700,000 individual dinoflagellates. Working in unison, they transform the bay into a high-resolution reactive screen. Every passing fish, every falling raindrop, every shift in the current becomes a vivid chemical signature. This dense biological network acts as a merciless indicator of aquatic purity. The chemical factory demands perfect salinity and a precise nutrient balance to function. Yet this entire underwater optical system remains highly vulnerable to the surface world. The creeping glare of coastal artificial illumination bleeds into the bay, easily overwhelming the delicate glow of the microorganisms, quietly blinding the living ocean until the microscopic sensors fade into the polluted night. While marine microorganisms use light as a fleeting chemical signal, the forests of Java engineer permanent biological architecture on a massive scale. Inside the Djawatin forest, the Samanea saman, commonly known as rain trees, construct a solid living roof. These timber pillars have stood for over 100 years. Their horizontal branches stretch outward for up to 100 feet, rivaling the wingspan of a commercial airliner. The rough, deeply fissured texture of the bark serves a strict mechanical purpose. It acts as an anchor. Dense blankets of wet ferns and wild orchids plaster themselves across the massive trunks. Zero parasitism. The host tree bleeds no nutrients. These epiphytes simply exploit the vertical elevation to break through the canopy shadow and capture direct sunlight, transforming every individual tree into a self-sustaining vertical garden. Millions of layered leaves trap evaporating moisture, driving local temperatures down. This dense biological canopy actively seals off a highly regulated microclimate, maintaining a humid ecological fortress right inside a heavily exploited agricultural zone. While tropical humidity engineers dense biological life, the barren plains of Kazakhstan construct absolute geological paradoxes through a brutal conflict of subterranean water and extreme cold. How can pressurized thermal water build a towering cone of solid ice? The answer lies in extreme thermodynamics. The formation perfectly mimics a classic stratovolcano, yet instead of incandescent magma, this crater consists entirely of hollow ice. Above ground, the winter air bites with a searing cold of -30 degrees Celsius. Deep below the permafrost, immense geological pressure forces warmer liquid toward the surface. Heat meets freezing void. The conflict is instantaneous. Thermal water violently breaches the crust. Searing atmospheric cold immediately crushes the escaping steam. The liquid undergoes a massive thermal shock and crystallizes within milliseconds of hitting the air. Drop by drop, layer by layer, the freezing spray continuously fuses onto the rim, rapidly stacking a hollow spire that towers 14 meters into the sky. A continuous pillar of vapor billows from the frozen vent. It is an active, erupting glacier. This thermal anomaly serves as a functioning laboratory of planetary cryovolcanism, perfectly mirroring the deep space physics that currently drive the icy geysers above the hidden oceans of Saturn's orbital moon Enceladus. While a 14-meter hollow ice cone silently freezes over an underground thermal anomaly, the Hawaiian coast deafens with a completely different acoustic signature. Active, aggressive expansion of the Earth crust sounds like a continuous explosion. Liquid basalt meets the Pacific Ocean. A deafening hiss. The water vaporizes instantly. This extreme thermal shock violently alters the physical state of the material. The outer shell of the lava cools in milliseconds, contracting under immense mechanical stress. Basaltic glass glass shatters. The high-pitched crunch of disintegrating rock pierces through the heavy roar of pressurized steam. This violent vaporization does not produce harmless white clouds. The boiling seawater reacts directly with the molten rock to generate laze, a dense, highly toxic acidic haze. This rolling fog carries lethal concentrations of hydrochloric acid and microscopic shards of volcanic glass, possessing the corrosive power of battery acid. Beneath the turbulent surface, the shattered fragments pile up on the ocean floor. The shoreline pushes outward, meter by meter. The expanding landmass displaces thousands of cubic meters of water, functioning like an untamed industrial furnace working at maximum capacity. However, this newly born territory lacks a solid geological foundation. The fresh lava deltas sit precariously on steep, loose slopes of underwater rubble. They possess the structural integrity of a house of cards. Massive sections of the new coast routinely shear off and collapse into the abyss without a single warning sign, violently exposing the raw, incandescent rock underneath to trigger a new wave of explosions. Genesis is a toxic, explosive, and fundamentally dangerous mechanical conflict. The primary architectural tool of the planet operates at exactly 1,100 degrees Celsius. While Hawaiian basalt aggressively expands the physical crust from below, the planetary envelope takes the heavy hits from space. The strike originates exactly 150 million kilometers away. The sun ejects a massive wave of charged plasma. This radioactive storm tears through the vacuum at 3 million kilometers per hour. The target is Earth. Without defense, the solar wind would instantly strip away the atmospheric layers. But the cosmic onslaught hits an invisible barrier, the magnetosphere. This colossal electromagnetic shield generated by the spinning iron core of the globe intercepts the radiation. It acts as a massive deflector, catching the lethal plasma and funneling it violently along magnetic field lines toward the northern and southern poles. The atmospheric entry is a high-speed crash. Charged particles slam into atmospheric gases, instantly converting kinetic energy into visible photons. The altitude dictates the exact chemistry of the flash. Above 200 kilometers, the solar barrage hits highly rarefied oxygen molecules. The upper sky bleeds deep red. Lower down, exactly 100 kilometers above the surface, the gas density heavily increases. The reaction shifts. The entire horizon detonates in neon green. This polar glow is not a random atmospheric decoration. It is the visible friction of an active planetary armor. The electromagnetic field continuously repels the lethal cosmic bombardment, shielding fragile orbital satellite networks and securing the critical power grids of modern civilization from total collapse. While the planetary magnetosphere repels cosmic radiation in the vacuum of space, the lower atmosphere subjects biology to a brutal physical crash test in the frozen wilderness of Lapland. Extreme low temperatures collide with persistent winter humidity. Supercooled water droplets from low-hanging clouds strike the needles of spruce trees and freeze instantly upon impact. The process is called tikilumi. It is a slow, methodical encasement. Layer by layer, the hard rime builds up, transforming ordinary timber into dense white columns. These asymmetric formations act as a frozen chronicle of the Arctic winds. The ice accumulates heavily on the windward side, recording the exact direction, duration, and intensity of every winter gale directly onto the forest canopy, a living weather archive. The accumulation is relentless. A single tree can carry up to 4 tons of solid ice. That is the equivalent weight of a commercial delivery truck pressing down on a single wooden trunk. The physical strain is immense. Under this staggering vertical load, massive trunks bend entirely in half until their highest branches scrape the frozen earth. Yet, the timber rarely snaps. This extreme biomechanical flexibility of the wood is a critical mechanism of adaptation to a hostile environment, silently forming the resilient geological memory of the species. In the arid landscapes of southwestern Morocco, gravity yields to hunger. This is a biological anomaly where mammals occupy the ecological niche of birds, adapting to a regime of extreme drought. The anatomy of a typical even-toed ungulate features rigid keratin designed for flat horizontal plains. It is built for running, yet the biomechanics of these herds rewrite the laws of physics at altitude. A vertical ascent of 10 meters for a goat is equivalent to a human scaling the sheer wall of a 3-story building without safety gear. The secret lies in the precise engineering of their extremities. Elastic toes separate widely, gripping the curved wood. A dry scrape echoes as the soft, rubbery inner pads of the hooves press tightly into the rough, deeply fissured bark of the argan tree. From a macro view of this mechanical locking action, the perspective pulls back. An entire herd hangs suspended in the dense canopy, balancing effortlessly on precarious branches. These hooves function as integrated climbing gear. The cloven structure allows each half of the hoof to move independently, matching the unpredictable topography of the branch. The convex inner pads generate massive friction. This anatomical anchor allows the animal to securely harvest the nutrient-dense argan fruits. The process of vertical foraging immediately launches a cycle of natural reforestation. The goat digests only the fleshy outer pulp of the harvest. It later spits out or excretes the iron-hard inner nut across the dry territory. The eaten fruit becomes a new tree. A continuous hydroacoustic white noise fills the deep water. If in the desert, survival depends on the individual biomechanics of hooves, in the ocean, evolution scales to collective neural networks, turning thousands of fish into a single organism. The muffled vibration comes from countless small bodies displacing water in a highly synchronized rhythm. There is no panic in this formation. It is a strict geometric defense algorithm driven by the selfish herd theory. Every individual instinctively fights its way toward the core of the mass to minimize personal exposure. The result is a dense, perfectly rotating silver sphere. To maintain this fluid structure without a single collision, the school relies on absolute hydrodynamics. Each fish uses a specialized sensory organ called the lateral line. It constantly reads the acoustic frequency of the environment and registers micro fluctuations in pressure from neighboring fins. The school does not just see the movement, it feels the physical displacement of the water around it. The data processing is instantaneous. The synchronization of thousands of bodies occurs in just 3 milliseconds. That is 100 times faster than a human blink. A single shift on the outer edge drops the local water pressure, and the entire sphere recalculates its collective trajectory. Pure biological mathematics. The frantic noise of the swarm gradually merges into a unified, tight hum. The massive, spinning silver structure simply hovers in the dark blue void, suspended in absolute aquatic weightlessness, right before the inevitable strike of a predator. Marine biomass coordinates through changes in water pressure, but aerial swarms rely on a navigation system of an entirely different order. They read the magnetic field of the Earth. A monarch butterfly weighs less than 1 single gram. Its microscopic body appears too fragile to withstand a moderate gust of wind. Yet a sudden zoom out to a satellite map reveals a brutal transcontinental trajectory spanning 4,500 kilometers from the northern plains of Canada to the central highlands of Mexico. For an organism of this exact size, completing such a massive route is physically proportional to a human walking around the entire globe twice. Pure endurance. The mechanics driving this flight rival the most advanced human avionics. The insect does not merely drift, it calculates. Deep within its antennae, a biological circadian clock constantly synchronizes with the shifting position of the sun. When thick storm clouds block the daylight, a secondary internal failsafe immediately activates. Specialized light-sensitive proteins, cryptochromes, allow the butterfly to physically perceive the planet's magnetic lines of force. A built-in quantum compass, absolute navigation. Upon arriving at the high-altitude fir forest, the swarm faces a severe environmental shift. Nighttime temperatures plummet near freezing, threatening to crystallize the insect's vital fluids. Millions of butterflies tightly grip the cold, rough tree trunks, layering their fragile wings into dense, heavy clusters. Collective thermal radiation begins. The continuous microscopic shivering of millions of pulsating bodies generates an active microclimate, trapping precious heat inside the living blanket. An isolated insect would perish overnight. Millions acting as one form a biological furnace. Morning sunlight eventually pierces the frost-covered forest canopy, rapidly raising the core temperature of the entire massive swarm. Reacting to the thermal surge, millions of winged insects simultaneously detach from the bark, launching into the morning air to continue the global chain of pollination. Biological systems migrate across continents in months, while geological chemistry builds its monumental structures over millennia, molecule by molecule. Deep below the crust, intense tectonic pressure forces groundwater through ancient limestone deposits. The heated fluid dissolves massive quantities of calcium carbonate. The pressurized solution surges upward through narrow bedrock fissures. It violently breaches the surface. Oxygen hits the thermal water. A sharp hiss of escaping carbon dioxide cuts through the air. The chemical equilibrium shatters in an instant. Stripped of its trapped gas, the fluid can no longer carry its dissolved mineral burden. The transformation from liquid to solid happens in real time. Microscopic molecules of calcium carbonate precipitate directly out of the current, crystallizing into rigid travertine rock. Over thousands of years, these invisible building blocks have engineered a blindingly white mineral architecture the size of an entire mountain. A petrified cascade. The deposition adds merely a few millimeters of new stone each year, yet this active chemical factory never stops shaping natural pools and rigid terraces, turning flowing water into solid earth right before your eyes. The infinite crystallization cycle sustains itself through one unyielding metric. The liquid emerges at a stable 35 degrees. To capture these millennia-old reactions and microscopic sensors, human technologies had to adapt just like nature itself. Observation is no longer enough. The connection between the creator's lens and the viewer's mind now operates entirely through the prism of neural networks. A frame of a steaming mineral terrace abruptly stutters. A violent visual glitch tears away the physical stone, instantly projecting a precise digital wireframe over the subterranean mechanics. Processing just 1 minute of this layered environment demands computational power equivalent to calculating the structural stress of a full-scale suspension bridge. We actively fuse real expedition footage with artificial intelligence reconstructions and complex digital simulations. Which of these survival algorithms challenges your logic? Optical lenses have strict limits. Digital tools have only just begun to reveal the hidden architecture of the planet, leaving a vast mathematical frontier for new explorations.